Okay, so we have a log function to solve. We have the same base of 5. So that allows us to use a log property of log. So having same base allows you to condense it, log of base of 5, and then these functions can multiply together within the same log of base of 5 function. Okay, next thing we can do is to get rid of this log of base of 5 by the exponential, because of 5 to the x and log of base of 5 are inverse to each other, so we can apply that to both sides of the equation. So that way this cancel. We have 3x minus 1, 4x minus 5, and 5 to the power of 0, or anything to the power of 0 will be 1. Okay, next thing we can do is FOIL it and try to condense this as a quadratic standard form. So let's FOIL it. 3x times 4x will give you 12x squared. On the outside we get negative 15x. On the inside we have 4x, and on the last two terms, negative 1 times negative 5 will give you positive 5. We can combine the like terms. So 12x squared minus 19x, subtracting 1 on both sides will give you plus 4 equals 0. We can factor it, but at the same time we can just go straight to quadratic formula because it's not very fun to play with a big leading coefficient. So I'm gonna use negative b plus or minus b squared minus 4ac divided by 2a, and that's equal to x. So in this standard form, a equals 12, b equals negative 19, c equals positive 4. When you plug in those values, negative or negative 19 plus or minus negative 19 squared minus 4 times 12 times 4, all within the radical, and divided by 2 times 12. So negative 19 makes you positive 19. 19 squared I think is a 361, and this is 361, this is 48. 48 times 4, 192. So we subtract 192 divided by 24. So 361 minus 192, we get 9, 6, 1, 169. Okay, so that's a good number to square root. 169, square root of 169 is 13. So 19 plus 13 over 24, or 19 minus 13 over 24. So here you get 32 over 24, or 6 over 24. So you can simplify this as 1 over 4, or if the greatest common factor between 32 and 24 will be 8, so it ends up becoming 4 over 3. So you either can have 4 over 3 or 1/4, but you must double check these answers to the original equation to determine if these are extraneous solutions. So if you plug it into the first one, let's test or double check 4 over 3. Okay, this is fine because you have a log of 3. This okay, 16 over 3 is over 5, so we're not making it equal to 0 or negative. So when you get non-negative log of function, you're in good shape. So 4 over 3 should work. We'll double check with our calculator. Let's test x equals 1/4. By the way, this is x equals 4/3. So log of base of 5, 3 times 1/4 minus 1. Okay, the moment I say I don't need to test anything else. The reason is 3 over 4 is 0.75, and subtracting 1 from 0.75 will cause the log of function of base of 5 to be negative. Log cannot have any negative value in it, or 0. That's not possible, or at least for real solutions. So what happened was that this 1/4 became extraneous solution. So we should rule that out. Your final answer should only be 4 over 3. And that's how you do this problem.